Hi, welcome. My poster presentation is on application of nanobody as a diagnostic tool and the antiviral properties against maize rhizome necrosis. It is based on my research proposal. I am Faith Njero, a student at Sokoine University of Agriculture under the Partnership for Skills in Applied Sciences, Engineering and Technology, PASETS Scholarship Program. Antibodies are Y-shaped molecules. They have a long history where they have been applied in diagnostics and also for therapeutic purposes. So they are made up of 2 light chains and 2 heavy chains. However, the structure of the antibody it's complex, which limits its applicability in various research areas. So mainly for application for use in diagnostics. So it's mostly raised the serum. It's mostly raised in rabbits, and use of recombinant antibodies for immunoassays it's limited. Though even there are fragments of the antibody which have been designed, such as the VIB fragment and single chain variable fragment, which is made up of the variable region of the heavy chain and the light chain. Their stability and solubility limits their production as recombinant antibodies. However, in the serum of camels, it was discovered that they have a unique type of antibody which lacks the light chain, known as the heavy chain only antibody. So the heavy chain only antibody, its antigen binding region, it's made up of a single protein domain known as VHH, also commonly known as the nanobody. It's small, it's stable, and it can be produced. It's soluble and can be produced in large amounts in microorganisms, and it's tolerant to reducing environment, which makes it a nice property when it's being applied to be produced in the cytoplasm of plants. If you want to test the neutralization of the nanobody against plant pathogens. Maize rhizome necrosis, it's a disease of maize which is caused by double infection of maize chlorotic motor virus and sugarcane mosaic virus. So these are maize plants which have been from farmers' feed, which have been naturally infected by MLN. It leads to yield losses of up to 100%. So for control of this disease, we need to have rapid tests to detect the disease early on in farmers' feed, in seed companies, and also for exchange of pathogen-free germplasm across borders. So and also we need the deployment of tolerant varieties, as the release of a rich germplasm which are tolerant to the disease is the most viable way for control of viral diseases. So the objective of this study will be to develop a rapid lateral flow assay for the detection of both MCMV and SCMV using nanobodies, and to engineer nanobodies mediated resistant against MCMV and SCMV. For the methodology, I will have the antigen, the code protein gene for MCMV and SCMV as my antigen, which I'll mix with the adjuvant, and then I'll do camel immunization. Then I'll have RNA extraction converted to messenger RNA. Then using molecular biology techniques, I'll have to make the VHH library using nested PCR. So using VHH specific primers, I'm first amplifying the region from VHS to the H part, and then I go to the VHH specific region. Then through the library created, I do a phage display and biopanning to select for MCMV and SCMV positive binders. From the positive nanobodies identified, I'll use them, test their specificity and affinity against both viruses, MCMV and SCMV, and test their consistency performance against the commercially available immunoassay kits from BioLabor and Agdia for detection of MCMV and SCMV. And use the the nanobodies which are of superior specificity and affinity to develop a rapid acid kit which will validate for detection of the pathogen. Then for the second objective, the agroinfiltration of maize plants with the identified nanobodies, and then to see if they confine a resistance to both MCMV and SMV. Sorry, can't be able, I won't be able to share any results from this work, but some studies done such as identification of nanobodies against tulip virus X, they have shown to be excellent compared to the polyclonal type of antibodies, and also a study done against the grapevine fungi virus where they tried to see if nanobodies could confer resistance. So they showed through neutralization that the plants using the model plant Nicotiana benthiyama, which could express the nanobodies, was tolerant to the virus following mechanical inoculation experiments. I want to acknowledge SACITS and ICIPE, and thank you.